Hello students, today we are going to learn about rotational dynamics. In rotational dynamics, we are going to study about circular motion. Rotational motion. Yes. So when we concentrate on circular motion, the word motion indicates particle changing its position from one point to other point. When this happens, we'll call it as a linear motion. In linear motion, we define some physical quantities as displacement, S, velocity, V, which is a rate of change of linear displacement, and acceleration. Which is rate of change of linear velocity. These quantities, linear displacement, linear velocity, and linear acceleration, are being related with each other by kinematical equations. We have studied these kinematical equations as V is equal to U plus AT, the first kinematical equation, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS, where V is the final velocity after time t, U is the initial velocity, A is acceleration in the body, and t is the time for which the body is in motion. S is the displacement in the body, when U is the initial velocity, t is the time required, and A is the acceleration. And so the relationship between the final velocity, initial velocity, acceleration, and displacement. When we consider about a circular motion, object or particle moves on the circumference of circle. Suppose O is the center of the circle, R is the radius of the circle, and object or a particle is present at position A on the circumference of circle. If the particle is set into motion, then it moves on the circumference of the circle either in anti-clockwise direction. As it moves, will return back to A position again. And this will happen again and again. If it starts moving in clockwise direction, then it moves and return back to its initial position again, and it happens again and again. And so from this, we understand that circular motion is unidirectional motion. Either the particle will move in anti-clockwise sense or it will move in clockwise sense. But the important part of circular motion is it is periodic motion. It means when the particle starts from any initial point A, after some time interval, it will return back to the same position again. And so as it continues, after certain time interval, the particle comes to the same position again and again. This time interval is called as period of circular motion. Usually, period of circular motion is denoted by capital T. It is measured in terms of seconds. When we see the examples of circular motion in our day-to-day life, we are able to observe many natural phenomena where circular motion is there. Our earth revolves around the sun is a circular motion. Moon revolves around the earth is circular motion. If we tie a small object or a stone to a string and if we whirl it around our head, then when it moves, it is a circular motion. As we see the merry-go-round or a giant wheel, the cradles which are attached to this circular rim, when it starts moving, these cradles perform circular motion. So in circular motion, again we define some of the physical quantities like angular displacement, it is denoted by theta bar. Angular velocity, it is denoted by omega bar. Angular acceleration, it is given by alpha bar. So alpha is angular acceleration, omega is angular velocity, and theta is angular displacement. Angular displacement has SI unit as radian. We usually write it as rad. Angular velocity is rad per second, and angular acceleration is rad per second square. Like the linear motion, we are having the kinematical equations. There is a striking similarity or analogy as we are able to give the kinematical equations for angular or circular motion as omega bar will be equal to omega naught bar plus alpha into t, where omega is final angular velocity or angular velocity after time t. Omega naught is the initial angular velocity, alpha is angular acceleration, and t is time for which this change in velocity takes place. Theta is equal to omega naught into t plus 1/2 alpha t square. Theta is angular displacement, omega naught is the initial angular velocity, and alpha is angular acceleration, t is the time for which the circular motion is taking place. Omega square is equal to omega naught square plus 2 alpha theta is the third kinematical equation. And so in this way, we are able to give the kinematical equations for circular motion, or this can be used for rotational motion also. Now as we are discussing about the circular motion, the rotational motion is also a special case of circular motion. As we have seen, in case of the circular motion, the entire body moves along the circumference of the circle. The axis about which the body is moving is outside the body, and the distance between the axis of revolution and the object, this distance is the radius. In case of rotational motion, object itself or the body itself spins around itself when the axis of rotation passes through the body. As we see the example of rotational motion, if we take the example of Earth spins around itself. The spinning moment of the Earth is an example of rotational motion. Axis of rotation passes through North Pole and South Pole, and Earth spins around itself. This is rotational motion. If we take a top, the top rotates about the axis of rotation which passes through it. So the spinning motion of the top is rotational motion. If we take a ball and if we spin it, it performs a rotational motion. And so there are many other examples of rotational motion. In case of the rotational motion, what happens so? As the entire body spins around itself, body itself is made up of large number of tiny particles. These particles are situated at different points from the axis of rotation. So consider the perpendicular distance from the axis of rotation up to these particles which constitute the entire body. So as the body spins, as the body rotates, individual particles perform circular motion. So when the body rotates, the individual particles of the body perform circular motion. For example, as we all are situated on the surface of the earth, when earth spins around itself, we all perform circular motion about the axis passing through the center of the earth. When we consider about the circular motion, in 11th standard, we have learned some relationships between the linear and the angular velocity. As we know, any of the object or a particle, if it is going to perform a circular motion, it possesses a linear velocity. This linear velocity is always tangential to the circular path on which the particle is going to perform circular motion. Let V be the velocity of the particle on the circumference of the circle. After some time, the position of the particle changes and it goes to the new position. At this particular point, it possesses a linear velocity, and this linear velocity will have the magnitude v. Here we see that the radius vector OA vector represents the initial position of the particle on the circumference of the circle. Vector OB represents the position of the particle after the time duration small t. During this, as the particle moves from A position to B position, the two radii vectors inscribes an angle AOB. Let us measure this angle as theta. If the magnitude of the velocity v remains same, but if the direction of the velocity changes, then in such a case the motion is having an acceleration, because here the velocity is changing. When velocity changes in given time period, then it constitutes an acceleration. But over here, if you see the magnitude of the velocity remain constant, as the direction is only changing, so such type of motion will be called as uniform circular motion. In case of uniform circular motion, magnitude of velocity will remain constant, but its direction is going to change. In such a case, then we see that angular acceleration becomes zero, but the linear acceleration, which is not zero but is always acting on the particle and its direction is always toward the center along the radius, and this is called as a radial acceleration or a centripetal acceleration. So whenever particle moves on the circumference of the circle, but if the magnitude of the velocity remain constant, then the type of circular motion is called as uniform circular motion,